Okay. So since it depends on x, I need a table of x's and slopes. So slope, by the way, is also your dy dx. Yes?
Yeah.
So if I pick x values, what I'm going to do is you make slope fields on dot paper. My dot paper is a little bigger than yours. But usually they're about your size, the ones you have. I know the book has that size. Okay, because slope fields take a long time. This one won't, because it only depends on x. So what I do here is I look at x. What's my x value along this line? 0. So I say if x is 0, plug it in, what is the slope? 1. So when x is 0, so all along this line, the slopes are 1. I want you to use a ruler. Okay. So I want you to be fairly accurate. That's the slope of 1, up 1 over 1, right?
Yeah.
So draw a little teeny tiny line segment.
Oh,
Just a little chunk, not a whole line. And I'm going to do that all the way.
Does it go both ways? Like, it does it go to the left and right of the line? Like how yours are, like, or does it matter?
Oh, I get what you're saying. Yeah, it should go a little bit in each direction, yeah. Just like mine, yeah. Okay, here, my x values don't say 1, right? We can't use 1, because what's cosine of 1? Right? So what should I pick here? Pi over 2. Let's do pi over 2's. So, if x is pi over 2, plug it in, what's my slope? 0. So, all along this, all my values are 0. So that one, you shouldn't really need a ruler, but it might help. We have a slope of 0. Here, well, if that's pi over 2, that means that by default is pi. Yep. So what will I get if I plug in pi? Negative 1. So use a ruler. Or do you have that line?
No, we don't have those ones.
No. You can add, a little bit there. It might help. Just so you have the same as me. We're negative 1. That's a little off, but. Because I want you to be accurate there, as accurate as you can. Down 1 over 1. Down 1 over 1. Okay. So over here, what value is that? Negative pi over 2. So add in your table. What is cosine of negative pi over 2? 0. So all along that line, once again, 0. And the last place is negative pi. What's my slope there? Negative 1. So use your ruler, add a row of dots for you, just so it's the same as mine. When you're done, grab a calculator. We're waiting for you. We'll get there. Will be right. Alright, does everyone's slope field look like this? Now, when we're done, it should give us an idea of what the function looks like. But here's the thing with slope fields. If you only have a few dots, it's harder to see. The more dots I do, for instance, I only did pi over 2. I didn't do pi over 4, pi over 3, pi over 6. Get that? If I would do more dots, I would get a better idea. So let me show you the calculators. You need to be able to do a SlopeField on your calculators. Okay, so everybody go to a graph, clear out anything you've got in there. All right, new thing. Let's go to menu. Go away. Menu, graph entry. We're usually on function, right? By the way, it can now do, excuse me, equations, which is new than your old calculators won't graph equations. This one will. Well, which one do you think I want? Differential equation. That's what I have. So change the mode of your graph, and it does really nothing other than it pops up y1 prime. Do you see that up there? Little tiny little tick. It's easy to miss if you're not looking. So I'm going to type in, let's say y prime, so dy dx, is cosine x, and hit enter. Then I'm actually going to change my menu, or my window. I'm going to change it to maybe trig. See that give me a bit better picture?
There's still a graph.
What's that?
You still have like another graph.
A function graph or SlopeField graph?
Yeah, a function graph. I deleted it.
Go back and try to delete it again. So change your mode back to function and you play with my window. See if I can do anything better. Trig, it's as good as it's going to get, I guess. Well, it doesn't look very good. It's a little better. I zoomed in a bit. I'm going to zoom out. Looking at that, you should start to see a curve. Okay, can you kind of see how I curve down and then I curve up? Can you kind of see the motion there? Now, why is it a ton of them?
Because it's the plus.
Plus C, right? Because don't I have infinite many antiderivatives? So we have no idea where this curve is on the y. But we can get an idea of what the curve looks like. Can you kind of try to draw a solution in there? Yeah? So let's do that. Because a lot of times on a multiple choice, a question will ask you to draw a particular solution through the point here. So you kind of have to just kind of go with the flow and draw a curve. Now, here's the beauty of those type of questions. There's usually more than one right answer. In fact, more common would be the question, which one is not a solution? So it might give you several different ones. Because I don't have to have this whole curve. Maybe I thought it was just a parabola here. That would have been right too. Okay. So a lot of times you just, which one, and actually I think they're common sense problems. Nobody should miss them. And people do. You just kind of look. If one goes against what the little lines are doing, it's obviously not a solution. Okay. All right. So beautiful there. You're not impressed. That's an amazing thing that these calculators do. The other calculators do not do this. Yeah.
I didn't do anything even close to that.
Anything you, oh, I wonder if you're still in, yeah.
It was already on that one.
Oh yeah. Let me see your settings though. This may be one that Jacob or used. It's on radians. more typical one. I want you to write down the question first. Draw a slope field for the differential equation dy dx equals x plus y. Ah, that's why. Different settings for this graph than it is for the general calculator. That is weird. There we go. That makes sense. Ah, we're good. All right. Here is a more traditional slope field. You think about it. You're now depending on both x and y. Do you know an antiderivative for x plus y? No, because y is a function in and of itself. It's like backwards implicit differentiation, right? You cannot get an antiderivative for that, period. Okay, don't mistakenly say the antiderivative is 1/2 x squared plus 1/2 y squared. No. Your variable is x, right? dy dx. So y is a function. So, this we'll do later. This is telling me after I see, the graph, slope field, I want you to draw a solution through this point. There's more than one right answer to that. Okay, but here, now our table has both x and y because it depends on both variables. So, looking at my graph, I have to go point by point. I can't do an entire row now. So at the point 0, 0, I'm going to draw my table here. I'll have to keep going back and forth. dy dx is what?
0.
0. So I get slope is equal to bless you. Now let's go here. This is the point 1, 0. Plug them in. My slope is 1. So use a ruler because I want you to be accurate. So 1 over 1. Here, and I'll keep doing what you have. This is the point 0, 1, so its slope is 1. This is the point 1, 1, so its slope is 2. So it's going to be a little steeper. Try to do your best to kind of go 2. So that's why you have a ruler, kind of go up, down 2 over 1, or whatever you have room for. What do you guys have?
We go up to
Okay. Let's do another one here. So this is the point 0, 2. My slope once again is 2. This is the point 2, 1. My slope is 3, so it's even steeper.
2, 1.
Oh, 1, 2, sorry. Yeah. Let's go down here. This is the point 1, -1, so your slope is 0. So I will expect this. I know it's tedious, but all right. So let's do up here. This is the point -1, 2. So my slope is 1. Oh, am I still recording? Might take a while. Upload that one on YouTube. -1, 1. The slope is 0. Here, point -1, 0, -1. And finally, -1, -1, I'm down -2. Shut this off. So that'll take all day to upload to YouTube. Be able to crop it. Yeah.